I'm going to explain today a very important part in boron family, and we will see children today about the chemical properties of boron. Boron is a typical metal. It is very hard metal, children. Very hard metal. It is very similar to aluminium. Now, first today we will see reaction with acids and bases. This is the very important point. So children, as you know, it is having the metallic character, so it reacts with acids and bases. So it reacts with acids and bases to form corresponding substances. Corresponding substances means just like it is a metal. So it will react with any acid or any base to form the corresponding substance. And what is the corresponding substance? Corresponding substance is salt or salt-like substances. So first, children will take the case of boron. Boron, it reacts with sulfuric acid. So there is formation of S3BO3 plus SO2. This is boric acid. Boric acid S3BO3. Similarly, when boron, it reacts with HNO3, nitric acid, both are concentrated, children, because boron is highly stable element. And so again here it is S3BO3 and plus NO2. In case of sulfuric acid, we get the SO2. In case of nitric acid, we get the NO2. This is all, children, about the one point. Now children, boron is highly reactive, and boron forms boric acid. Boric acid, it is acidic in nature, but it is very weak. It is very weak acid. Very weak acid. We'll see about boric acid later on, that what is the effect of, what is the usage of boric acid. So here, reaction of aluminium. Aluminium is attacked by HCl, and there is formation of aluminium chloride. And children, here there is the liberation of hydrogen gas. Now when we take aluminium, and here there is NaOH. Here there is NaOH, and so NaOH, and there is formation of other compound, and it is the salt, sodium aluminate or sodium meta aluminate. So NaAlOH4. Here there will be, here there will be also liberation of hydrogen. This is sodium aluminate, or we may say sodium meta aluminate. Now children, you have to keep in mind that boron also reacts with bases and it forms the salt and water, just like this acid. So boron plus NaOH, here NaOH equals, just we have to heat, children, because boron is very hard element. Children, boron is very hard element. So little amount of heat has to be supplied, and there is formation of salt, sodium borate. Sodium borate. This is sodium borate. Sodium borate is formed, and plus there is the formation of hydrogen gas. So this is, children, about the some of the reactions of boron family. So now this indicates that aluminium has amphoteric. Aluminium has amphoteric character. Amphoteric character means tendency to react with acid as well as with base. Here, aluminium has reacted with sodium hydroxide to form this. Here there is formation of sodium. This boron. So boron this form this. So aluminium, this boron forms sodium borate. Aluminium forms aluminum chloride and sodium aluminate. So this aluminium has amphoteric character because aluminium reacts with HCl to form the AlCl3 plus hydrogen gas. Similarly, aluminium reacts with NaOH to form this aluminium sodium aluminate, and so this indicates that this aluminium is amphoteric in character. Amphoteric character means whenever any substance reacts with acids and bases. So thus it is. So boron forms sodium borate, and so this is about the point. Now children, you have to keep in mind that indium and thallium do not react with acids and bases. Indium, thallium, they are quite resistant, and so they do not react with acids and bases. Indium and thallium. So this is one point. Now children, I am going to explain very important point. You have seen I had written the reaction of aluminium with HCl. Aluminium react with sulfuric acid also. If we say write aluminium plus H2SO4, let it be concentrated, and then the formation of aluminium sulfate plus hydrogen gas. But children, if you take aluminium plus HNO3 concentrated, here there will be no reaction. No reaction take place. Now it is very much important to note that in this condition there is formation of aluminium oxide. There is formation of aluminium oxide on the surface. So aluminium plus HNO3, there is formation of Al2O3 plus hydrogen plus NO2. Now you have to understand very clearly, children, that this is for the first time. For the first time, when we pour, when we add nitric acid, even it is concentrated, it forms quickly the aluminium oxide. This is aluminium oxide. Commonly it is called as alumina. And this alumina or this aluminium oxide is highly passive. This is highly passive. Highly Passive. Passive means it do not reacts. So now this principle of aluminium is very much used in making the containers which carries the nitric acid. So nitric acid is very powerful acid. It is one of the most powerful oxidizing agent. But it is used to prepare the tank. So very important point. Informed question. Explain why aluminium metal is used. Aluminium metal is used in making containers for transportation of concentrated nitric acid. This is very important part. So reason is very simple. When aluminium reacts with nitric acid, there is formation of aluminium oxide layer or alumina on the surface. Only the starting layer, it has the deposition of the alumina, and as a result it prevents. So simply just I had explained. See again, aluminium plus HNO3 concentrated. So there is formation of Al2O3 plus hydrogen plus NO2. So this layer, the passive layer of alumina, prevents aluminium from the further reaction. So what should we answer? There is the formation of passive layer in form of thin film on the surface of aluminium. Passive layer, thin film. It is not, your children, very thick. It is very thin. You have to keep in mind. It is very thin layer which prevents from further reaction. So it is very much important to note that this passive layer prevents from the further reaction. Now I am going to explain next part, reaction with halogens. So children, just like other metals, members of boron family also react with halogens to form corresponding halides. So members of boron family react with halogens directly or indirectly to form trihalides. Children have to keep in mind trihalides. Tri means three. Three halogen atoms are attached in one molecule, three hydrogen. And directly means direct combination. When two elements are react together, there is direct combination. When there is indirect combination means by treatment with some halogen acid, we treat some salt with halogen acid, and that is called as trihalide. So children, this boron, aluminium, they can react with the fluorine, chlorine, bromine directly. So let's see, boron plus F2. We heat absence of air. So there is summation of BF3. So you have to balance here. So this is boron trichloride. Similarly, if you take the case of boron plus, let it be aluminium plus chlorine. So there is AlCl3. Conditions will remain the same, children. So these are the direct method, and so here again 3Cl2. So children, these are the direct methods to prepare. On the other hand, we can prepare by taking some salt. We can take some salt to prepare the compounds. Now I will see the properties of halides. Now children, properties of halides, they are covalent compounds. Children have to keep in mind that they are covalent in nature. You know, they are covalent in nature. Covalent. They are water soluble, but they have slightly affinity toward the organic solvents also. So this is the covalent character. Means, you know, covalent compounds, they are water insoluble, but they have, you know, covalent nature. They are soluble in organic solvents also. Now coming to next point, they are Lewis acids. Lewis acids means, children, they have, you know, electron deficient nature. Lewis acid means they have electron deficient nature. Electron deficient nature. Fine. This is Lewis because they have 6 electrons in their valence shell. So this is the Lewis. Now see how they are. If we take this BF3, so see the structure. This F. Now the 3F are attached. So here there is, you know, there should be the lone pair, but actually it is the presence of 6 electrons only. Here there is no lone pair. No lone pair. Now, so if you see the electronic configuration, boron, atomic number 5, 2 and 3. So 3 electrons are present from the boron side, 3 electrons are present from the fluorine side. So see how it is. So this is the boron, 1 electron, 2 electron and 3 electron. And children, there is 1 fluorine, this is 2nd fluorine, and this is the 3rd fluorine. So there is covalent bonding. And so here, children, see very important part. So the compound will have how much electrons? 6 electrons. So 6 electrons in valence shell. I know 6 electrons in valence shell means the substance will require 2 electrons to complete the octet, and thus the compounds are this electron deficient, and as a result this BF3 will gain electron pair. If we take the ammonia, children, so this ammonia, it is electron rich. It is electron rich, and it is Lewis. It is Lewis compound. but here it is electron deficient. So it is Lewis base, it is Lewis acid, and so as a result of this, there will be like this. We write like this, and here there will be BF3. So there is the formation of addition compound. Ammonia, it is electron rich, it is Lewis base. BF3 electron deficient, it is Lewis acid. So this will give electron pair, and there is formation of this bigger molecule, and this is ammonia boron trifluoride molecule. Ammonia boron trifluoride molecule. See the name. And such compounds are called as addition. Addition compound. The two compounds, they are joined together, and there is formation of addition compound. Now children, one more point in this, the strength of the Lewis basic character. So the Lewis acid character decreases. Lewis acid character, this decreases in the following manner. This BF3, it is the weakest. BF3, it is weakest Lewis acid. Weakest because size of boron is very small. Then coming to BCl3, then BR3, then there will be BI3. So this is the trend. Weakest, it will be strongest. So this is about the Lewis acid character in terms of this, and so it depends on the size, children. Halogen is same, very strong is there. So this is very important part, and this you have to keep in mind, that how they vary, how they impart the character. Weakest Lewis acid, the strongest Lewis acid, and so this is all about the this Lewis acids, then the amphoteric nature of aluminium, and so.